Welcome back, dear children. Today we will learn chapter 14, Solids and Semiconductor Materials. Lesson 1. Today's objective is energy bands in solids. So remember the word energy bands. Bands means collection of, it is a collection. Energy bands means collection of energies. First, we will go back to atoms. From Bohr atom model, we have learned the equation for energy of an electron in the nth orbit of an atom. The equation, all of you know. What is that? En equals minus 13.6 by n square electron volt. From this equation, it is clear that energy of an electron depends on the orbit in which they lie. For electron in the first orbit, what is its energy? Minus 13.6 by 1 square. When you consider the electron in the second orbit, its energy is minus 13.6 by 2 square. Third orbit, energy is minus 13.6 divided by 3 square. It will go like this. So, electrons in different orbits have fixed amount of energy, fixed and discrete amount of energy. When you consider the electron in the first orbit, its energy is fixed, minus 13.6 eV. When we consider the electron in the second orbit, its energy is minus 13.6 by 2 square eV. Okay, so energy of electron in different orbital is fixed. This is the case of a single atom. And here we consider an isolated atom. Isolated atom, one atom alone. No other atoms are surrounding it. Now we are coming to a crystal. You know, in a crystal, we cannot see an isolated atom. All the atoms are surrounded by millions of neighboring atoms. But then what will happen? Electron in one atom is influenced by large number of electrons in the neighboring atoms. They are also influenced by the nucleus of other atoms also. So due to this interaction, when we consider an electron in the first orbit of a particular atom, for simplicity I am taking first orbit, its energy will not be 13.6 eV. It will be slightly less or more than 13.6 eV. If we consider another atom in a different position of the crystal, there also this will happen. So for that atom, for the electron in the first orbit, it will have a different amount of energy. It won't be same as the previous atom. So you know, in a crystal, each electron has a unique position. Depending on their position in the atom, the electrons, I am talking about electrons in the first orbit only for simplicity. Each electron will have a different energy. So you can see in a crystal, the first orbit electrons will have a range of energies like this. Suppose in a crystal, there are 1,000 atoms. So there will be 1,000 electrons in the first orbit. if you consider one electron in one orbit. So there will be 1,000 different energies. So this range of energies is known as an energy band. Similarly, when you consider the second orbit, the same thing happens. So this is the energy band of second orbit electrons. Third orbit also, like this. So this is how energy bands are created. I believe the concept is clear to you now. Okay. And the range of energies possessed by valence electrons is known as valence band. And there is one more band called conduction band. That I will explain later. Now we are considering a silicon crystal. When you consider a silicon crystal, so what is the atomic number of silicon? Atomic number of silicon is 14. If you write the electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p2. This is the electronic configuration. And what I told you, the formation of energy bands. You know, the interaction between the electrons is negligible for inner orbits. It is appreciably for only outermost electrons. Now I am considering the outermost shells only, S and P, 3s and 3p. And you know, in 3s, there are two energy levels. You know, two electrons are there. There are two energy levels. So 3s, two electrons will have different energy. Similarly, when you consider the P shell, it has three subshells, Px, Py, Pz. Here you can see 3p1, two electrons are filled, and the other two levels are empty. You know, each subshell Px can accommodate two electrons. Py has two electrons. So 3p orbit can accommodate 6 electrons, but only 2 electrons are there. So it has two energy levels. So totally, how many energies are filled? 3s2 and 3p2, 4 electrons. So valence shell contain 4 electrons. These 4 electrons have 4 energy levels. And also we can see in the p subshell, 2 levels are empty. P shell can accommodate 6 electrons, only 2 are there. So 4 are empty. 4 energy levels are without electrons. So we can see total number of energies in one atom is how much? Energy levels. Total number of energy levels in one atom is 8. Total number of energy levels in one atom is 8. When we consider a crystal of n atoms, so how many energy levels will be there? For one atom, 8 energy levels. In a crystal of n atoms, how many energy levels will be there? 8n energy levels will be there. In a crystal of n atoms, there will be 8n energy levels. And you can see that 4n levels are filled with electrons. 3s orbit has 2 energy levels. 3p has 6 energy levels. Out of this, out of 8n energy levels, 4n are filled. 4 electrons are only there in the outermost shell. Okay? 4n levels are filled. And 4n levels are unfilled or empty. And the 4n filled levels or 4n valence electrons have a range of energies. This form valence band. The 4n filled levels form an energy band called valence band. Okay? And the 4n unfilled levels, the range of 4n unfilled levels form another energy band. The 4n unfilled levels form another energy band. This energy band is called conduction band. And there is an energy difference between these two energy bands. This is called forbidden energy gap. The gap of energy between conduction band and a valence band. It is called a forbidden energy gap. Conduction band and valence band is called forbidden energy gap. Energy gap. So far, what all thing we have learned? A summary till here. We learned what is an energy band. What is an energy band? The range of energies possessed by the electrons. Energy band is the range of energy possessed by an electrons. How these energy bands are formed? Due to the interaction of the electrons of the atom. And we learned what is valence band, range of energies possessed by valence electrons. Another band is known as conduction band. The range of energies possessed by the unfilled levels in the atom is known as conduction band. And the energy gap between these two bands, conduction bands and valence band is called forbidden energy gap. So energy band. What is energy band? It is the range of energies possessed by the electron. Energy band is the range of energies possessed by electrons. Then what is conduction band? Valence band. Valence band, range of energies possessed by valence electrons or outermost electron. By conduction electrons, by outermost electrons. By valence electrons. Now we have learned is conduction band. What is conduction band? Range of energies possessed by the unoccupied levels, or we can say conduction electrons. When electrons come there, they become free electrons. Range of energies of the unfilled levels. Is called conduction band. So this is the energy band theory. And based on valence and conduction bands, we can classify materials into three types. We can classify materials as conductors or metals, insulators, and semiconductors. Now, how will you classify? So solids now can be classified into three categories based on energy levels. Classification of solids based on energy bands. So we can classify solids into three. First one is conductors or metals. Second one is insulators. And third one is semiconductors. Okay. Now conductors. For conductors, the conduction band will be partially filled. Partially filled there may be some free electrons. And valence band will be partially filled. Both the bands are partially filled. Okay. The top one is the conduction band. I call it as Cb. Bottom is valence band. Both are partially filled. And they overlap here. Overlapping. This is a case of conductors. This is known as energy level diagram. Here, forbidden energy gap is 0. When you consider insulators, conduction band is empty. No free electrons will be there. Conduction band is empty. And valence band is filled, completely filled. But this energy gap, forbidden energy gap, Eg, that will be very large. It will be greater than 3 electron volt. Even if you heat the material, electrons of the valence band cannot overcome energy gap and reach the conduction band. So they will not conduct. You know, insulators have high resistivity and low conductivity in terms of conductivity, if we say. In terms of energy band, energy gap is very high. Valence band is completely filled. Conduction band is empty. And when you consider semiconductors, the conduction band is empty only at absolute zero. At absolute zero. And valence band is completely filled. But this energy gap is small. It is less than 3 eV. So what will happen? If valence electrons gain energy, if they, due to temperature, they can gain energy, then they can move to the conduction band. They can overcome the energy gap. So even at room temperature, what will happen? Valence band, valence electrons of semiconductors move to the conduction band and their conductivity increases. So this is how we distinguish between metals, insulators, and semiconductors based on energy band theory. Okay, so once again I summarize. For metals, conduction band is partially filled. Valence band is partially filled. Forbidden energy gap is 0. Insulators, conduction band empty. Valence band filled. Energy gap very large, greater than 3 eV. And for insulators, conduction band, for semiconductors, conduction band is empty at 0. So so semiconductors behave like insulators at absolute 0. Cb is empty at absolute zero. Capital T means absolute temperature. Valence band is filled. Energy gap is less than 3 eV. So semiconductors behaves as insulators at absolute zero. You have to remember. Semiconductors behaves as insulators at absolute zero. So that is why as temperature increases, what will happen? More electrons gain energy and they can move to the conduction band. So the conductivity of semiconductors increases. So children, this is about the energy bands and how solids are classified into different category based on energy band. Okay. The solids can be classified into conductors, insulators, and semiconductors on resistivity also. Conductors have low resistivity. Insulators are high resistivity. Semiconductors resistivity is intermediate between conductors and insulators. Okay, children. So next topic we will do in the next lesson.